In this lesson, we're going to be learning how to graph absolute value function and also find its domain and range. So absolute value function is defined by this equation: y is equal to a absolute value of x minus h plus k. Now let's discuss how each of these parts, a, h, and k, influence the graph of absolute value function. Let's start with a. Now a determines the steepness of the graph. Now let me just draw a representation of graph of absolute value function. Now let's assume that this represents a graph of absolute value function of x. That's the parent function. So, and let's assume that the graph of this is this way, right? Now, seeing this equation here, we can say that a here is equals to 1. Now, if a becomes 2, now this graph will become a bit steeper. If a becomes something like 20, it will be closing more and more. So that's why I say that this a determines the steepness of the graph. Now, what if a is negative? Now, if a is negative, this graph is going to open downwards. Instead of having this V-shaped upwards, it's going to open downwards. So this now is the absolute value function of negative x. Alright. Now, if this a is positive, the graph will open upwards. If it's negative, it's going to open downwards. And then if a is a very large number, this curve tends to close the more. Then if it's a very small number, then it widens. So let's discuss h. Now this h shifts the graph to the left or right. Now if you look at this parent function, you see that here we have only x, which means that h is 0. So that is why the vertex starts from 0, 0, which is at this point. Now, assuming we have an absolute value function where y is equals to x minus 2, this h is going to be equals to 2, and then this graph will shift 2 places to the right. That is 1, 2. This graph is going to look like this. So that's what this h does, either to the right or to the left. Now, if you have y equals to absolute value function of x plus 2, we are going to write this to be in this form, x minus h. So it's going to be x minus 2. Remember, minus times minus is equals to plus. It's going to be x plus 2. So in this case, h is equals to minus 2. So here, this graph is going to move 2 places to the left and then take this form. Now let's discuss this k. K moves the graph either up or down. As when we have this absolute value function and the equation is, let's say, x plus 2, right? Absolute value function of x, then plus 2. These two here, the graph is going to move 2 places up. Now, it's going to be 1, 2. Now, this graph will start here. Okay. Now, if this is x minus 2, then it's going to be, we have 1, 2 here. It will shift 2 to the right and then 2 up. So, it's going to be like this. Now, another important part here is the vertex. Now, vertex is this point, this pointed part. Alright. So, it is gotten by h, k. So this is the vertex, and we're going to be treating h to be our x and then k to be our y. So you can see that vertex is equals to x, y. Let's solve practice problems. Let's consider this. So we're given y is equals to absolute value of x. Let's graph this function and find its domain and range. We are going to compare this with this definition of absolute value function. And then from here, you could see that h is equals to 0, and then k is equals to 0, and a is equals to 1. Now the vertex now becomes 0, 0, which is h, k. Now if you graph this function, the vertex is 0, 0, which is at this point, and then the slope is equals to 1, and 1 is the same thing as 1 over 1. That is rise over run. So we're going to move in 1 to the right and 1 up, 1 to the right and 1 up, 1 to the right and 1 up. We do the same thing to the left hand side. We move 1 to the left, 1 up, 1 to the left, 1 up, 1 to the left and 1 up. And then let's connect the dots. Okay, so it's just a sketch. Now this becomes the graph of the absolute value of x. Then what about the domain and range? So the domain of all absolute value functions are from negative infinity to infinity. That's all real numbers. Then the range is equals to from 0. Now the range of absolute value function always starts from this vertex. Now in this case, this graph opened upwards, so it's going to be from this vertex, which is 0, to infinity. If it's downwards, it will be from the vertex to negative infinity. So we have 0 to infinity. So know that this 0 is included, so that's why I used bracket to write it instead of this parenthesis sign. So let's move to the next question. So let's graph this function y is equals to absolute value of x minus 2, and in turn find its domain and range. So again, if you compare this function to this, we see that here h is equals to 2 and k is equals to 0. So the vertex is going to be 2, 0. Now we know that x is equals to 2 and then y is equals to 0. Now if you draw this graph, so we have 1, 2, so this graph shifted 2 to the right, which is at this point. What we have here as the value of a is 1, so it's going to be 1 over 1, so rise over run. 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, 1 up. Okay, so here we have 1 to the right, which is here, then 1 up, 1 to the right, 1 up, 1 to the right, 1 up. So this is how this graph will be. Now to write the domain and range, now the domain is negative infinity to infinity, which is all real numbers. Then range is equal to 0 to infinity. Now let's solve this question again. Y is equals to x plus 3. That's absolute value of x plus 3 plus 2. I want you to pause this video and try this question. Now here we have that a is equals to 1. H, we can see that the value of h here is 3. But then we're going to rewrite this to be in this form. So we're going to write this as y is equals to x, this plus 3 is equals to minus 3. Alright, because you know that minus times minus is plus. Then you have plus 2 here. So you can see that we have negative here, we have negative here. So we see that h is equals to negative 3. So we have h is equals to minus 3, and then k is equals to 2. Now the vertex is going to be minus 3, 2. So let's plot these coordinates. When x is -3, y is 2. So I have 1, 2, 3. Then this point, then y is 2, 1, 2. So let's trace it. Alright, so here is it. And then here is the vertex. Now the slope of this is 1. So 1 over 1, that is rise over run. 1 to the right, 1 up. 1 to the right, 1 up. 1 to the right, 1 up. We do the same thing here. 1 to the left, 1 up. 1 to the left, 1 up. 1 to the left, 1 up. And then this is how we plot the points. We have negative infinity here, we have infinity. We have negative infinity here, we have positive infinity. So the domain of this function is negative infinity to infinity. Then here, range is going to be equals to from this point upwards, and this point corresponds to y value of 2. Remember that range are y numbers or y values. So here is going to be 2 to infinity. So this is the domain and range of this function. Let's solve this one. Y is equal to 2 absolute value of x minus 1 minus 5. So let's compare this with this equation. Here h is equals to 1. Remember, we have minus a, we have minus a, so it's similar. H is equals to 1, k is equals to minus 5. Alright, so the vertex of the graph is at the point 1, minus 5. And then this slope here, a, is equals to 2. So it's going to be 2 over 1, rise over run. So let's sketch it. Here we have that y is equals to -5. So it's going to be 1, 2, 3, 4, 5. And then x is 1. But let me just add this one here. Then also add this one here, so that it will be easy when we be graphing it. Okay. Now let's plot the points. When x is 1, y is -5. When x is 1 here, y is -5. 1, 2, 3, 4, 5. Okay, this point. Okay, so this slope is 2 over 1. That is 1 to the right, and then 2 up, and then 1 to the left, then 2 up. Now let's start here. We have 1 to the right, we have 1, 2, 2 up, 1 to the right, 1, 2, 2 up, 1 to the right, 1, 2. So here we have 1 to the left, we have 1, 2, 1 to the left, 1, 2, 1 to the left, 1, 2. Notice that this is not drawn to scale, so this is going to connect this way, right? And then this way, don't know. Pardon me for that. So this is how it's going to be, but you understand the concept, right? So this point here is equals to -5. Okay, so to write the domain and range, the domain as always is going to be -infinity to infinity, which is all the numbers, and then range is going to be from -5 to infinity. We have from -5 to infinity. Now let's solve another example. We have that y is equals to -3, then x plus 2, absolute value of x plus 2 plus 1. So here a is -3, that's -3 over 1. H is equals to, notice that we have plus 2 here, so we're going to write this x plus 2 to be x minus -2, so that h will become -2, and then k will be equal to 1. So our vertex is equals to -2, 1. Now let's graph this function. So we have x here to be -2. So we have 1, 2. Let me add these ones. And then y is 1. Let me add this. Then also add these ones and these ones. Okay, so let's plot the points. When x is -2, y is 1. So here is -2 here, and then y is 1, which is here. So it's going to be, the point is going to be here. This is the vertex. Now, is it going to open upwards like this or downwards like this? Now, if you look at this a here, which is -3, this is a negative sign. And like I explained earlier, if it is a negative number, then it's going to open downwards. So since the slope is -3/1, we are going to be moving 1 to the right and then 3 down. So 1 to the right, 1, 2, 3, we have here. 1 to the right, we have 1, 2, 3. 1 to the right, 1, 2, 3. Then here, we move 1 to the left, then 1, 2, 3. 1 to the left, we move 1, 2, 3. 1 to the left, we move 1, 2, 3. So this is how the graph will look like. And then to find the domain and the range, the domain of this graph is all the numbers, and then the range is going to be from this point where y is equals to 1, then to -infinity. So this is the domain and range of this function. So let's solve this last example. We have y is equals to 2/3, then absolute value of x minus 1 plus 3. Now here our a is equals to 2/3, then h is equals to 1. We have negative sign here, so we're not going to write anything. And then k is equals to 3. So the vertex is h, k, which is 1, 3. And then this slope is going to be rise over run. So we have rise here and then run. So it's going to be 3 to the right, 2 up, and then 3 to the left, 2 up. Let's sketch it. Now let's locate these points. Now let's locate the points 1, 3. So we're going to have here is our 1, and then when y is 3, we have 1, 2, 3. So this is where it's going to be. And then since this 2/3 is positive, so the graph is going to open upwards. So we have rise over run. We move 3 to the right, 2 up, 3 to the left, 2 up. So 3 to the right, we have 1, 2, 3, then 2 up, 1, 2. 3 to the right, 1, 2, 3, 2 up, 1, 2. Here again, 3 to the left, 2 up, 1, 2, 3, 1, 2. Here, I have 1, 2, 3, 1, 2. So to be here. So this is how this graph is going to be. Then for domain and range, the domain is still all real numbers, and then the range is going to be from this point, and at this point y is equals to 3. Okay, so it's going to be from 3 to infinity. Now notice that you can also get all these points by just plugging in random values of x and then solving for y. That's another way to plot this graph accurately. Now, here's the catch. We already know that domain of absolute value functions are all real numbers. Now, how do we determine the range without plotting the graph? If you look at this equation, you see that this case equals to 3 is the y value of this vertex, and that is why the range always starts from. So the range of absolute value function is from k, comma, infinity, or it can be k, comma, negative infinity. Now here's the question: when do we use each of these? Use this first one when a is positive. So if this is a positive number, you make use of this. If a is equals to a negative number, then you make use of this. Remember, if a is negative, the graph will open downwards, that is from that point k to negative infinity. If a is positive, it's going to open upwards, that is from that point k to positive infinity. And then notice that this k can be negative or positive, it will not change anything.